Welcome to Mech Made Simple. Today we will be studying about adding forces in space. So till now, the forces that we were adding or resolving into components or finding the resultant of were all 2D forces. But now we will be studying how a 3D force acts and how it is resolved into its components. So for 3D force, we will take x, y, and z axis. So I'll draw here. So this is our three forces. This is x-axis, this is y-axis, and this is z-axis. Now the force F acts somewhat like this. So this is our force F. Now if I make a line here, if I make a line here parallel to x-axis and touching the y-axis, then that would be the Fy component. So this is the Fy component. From here O to, let's say this is A, this is B, so this is Fy component here. This portion is Fy. Now if I drop a perpendicular from A to the xz plane, to the xz plane here, then it would look like this. Now I have made a mistake here. I have drawn a line which is not uh, parallel to the x-axis. That would not be the case. So I'll just rub this. So this is our y-axis, and the force Fy component is parallel. This line would be parallel to the xz plane. So this is somewhat like this. Yeah. So this angle that the force F makes with the y-axis is called theta y. I'll write it here. This is theta y. And let's say this C, point C lies in the xz plane. Point C, mind you, lies in the xz plane. So this force OC makes an angle of phi y. I'll just check it here in the book. This is section 2.4. So this is phi. So this angle that OC makes with x-axis is phi. Now what would be the this angle is phi and this angle is theta y. So this would be f sine theta y, that is fh, the horizontal component. Now I'll just drop a perpendicular from point C to the x-axis. So it would look like this. It would be parallel to z-axis. So it would be like this. Let's say this is point D. Now I'll just check what all, if all the points are labeled. This is point O, this is point A, and that is our F vector. And what I have done is I have dropped the perpendicular from point A to xz plane, So that would be point C. So from C, OC, and let's say this point is OD. Let's say this line and this line are parallel. So I'll just make them parallel. So this is Fy, this is point B, this point is point B. So first, now we will resolve the force F into the components. Now we have made the diagram, the whole diagram. Now we will resolve the forces into its components. So one component we can naturally see is F cos theta gives Fy. F cos theta gives Fy. So we have Fy is equals to F cos theta y. And Fh is equals to Fh is this, that is OC, that will be equal to OAB, and AB is equals to F sine theta y. So I'll write Fh is equals to F sine theta y. So we have Fy and Fh. So Fh is the component of force in the xz plane, but we don't want the component of force in the xz plane, we want its rectangular components. So we will resolve this Fh into two components, and that would be Fh cos phi and Fh sin phi. So Fx would be Fh cos phi and Fz Fh sin phi. Now what is Fh? Fh is this, F sin theta y. So I'll just write this here, F sin theta y into cos phi, and this is F sin theta y into sin phi. So that is it with Fx and Fz. We got Fx, Fz. Now what is the relation between F and its rectangular scalar components? I'll write this here. Relation between magnitude of F, relation between magnitude of F and its rectangular scalar components, and its now we know that F is equals to OA, and F square would be equal to F square would be equal to OA square, and OA square is equals to OB square plus BA square. OB square plus BA square. That is the simple Pythagoras theorem that we are applying here. OA square is equals to OB square plus BA square. OA square is equals to OB square plus BA square. BA is equals to BA is equals to OC and OB and OC we can put values. OB is Fy and OC is Fh. OB is Fy and OC is Fh. We know that Fh is equals to Fh. Fh is equals to OC square and OC square. Fy plus OC square, and OC square is equals to OD square plus DC square. Fy plus OD square plus DC square. OD square plus DC square. Fy OD we have Fx, and DC we have Fz square. So we have F equals to Fy square plus Fx square plus Fz square. Now if we rearrange this, we can write it as, if I take root both sides, then F would be equal to root under of, I'll first write Fx square plus Fy square plus Fz square. So that is the relation between the magnitude of F and its rectangular scalar components. So we have resolved the force F into its rectangular components Fx, Fy and Fz. Now after this we will study about the relationship between the force F and its components. What is the angle relationship between the angles theta x, theta y and theta z with the force F and its components. Now this video is being too long, so in the next video I'll cover relationship of between force F and its components Fx, Fy and Fz, and the relation between the cos theta and Fx, Fy and Fz. So that will be covered in the next video. Till then, stay tuned. Please do like my channel, subscribe to my channel and share it among your friends. Thank you.